most people think Pluto is alone, a frozen dwarf planet drifting at the edge of the solar system, stripped of its title, left behind in the dark. But Pluto is not alone. It has a companion so large, so close, and so gravitationally powerful that the two bodies do not behave like a planet and its moon. They orbit each other around a shared point in empty space, a point that lies outside Pluto entirely. They are locked together, face to face, the same hemispheres staring at each other permanently as they circle that invisible pivot for billions of years. Charon is not just a moon, it changed what Pluto is. And by the end of tonight, you are going to understand exactly how one object turned a lonely world into half of a double system. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It is a simple action, but it helps this channel reach more curious minds like yours. Are you comfortable? Let's begin. Everyone knows Pluto, or at least everyone thinks they do. It is the small one, the cold one, the distant one, a frozen world circling the sun so far away that sunlight takes more than 5 hours to reach it. And when it arrives, it is so faint that noon on Pluto looks like deep twilight on Earth. Pluto is the world at the edge, the one that always seemed to exist, just barely within our grasp of understanding. A dim point of light that took more than 2 centuries of telescopic astronomy to find, and nearly a century more to visit. For 76 years, from 1930 to 2006, Pluto was the 9th planet. The smallest planet, yes. The most distant planet, yes. The odd one out, with an orbit so elliptical that it sometimes crossed inside the orbit of Neptune, and a path so tilted that it did not even stay in the same flat plane as the other 8. But it was a planet. It was on the poster on your classroom wall. It was the last entry in the mnemonic device that school children use to memorize the order of the worlds. My very excellent mother just served us 9 pizzas. Pluto was the pizza. It was discovered in 1930 by a young astronomer named Clyde Tombaugh, working at the Lowell Observatory in Flagstaff, Arizona. Tombaugh had been hired to carry out a systematic photographic search for a planet beyond Neptune, a search that the observatory's founder, Percival Lowell, had championed before his death. Tombaugh spent months comparing photographic plates of the night sky, looking for a tiny dot that moved against the background of fixed stars. On February 18th, 1930, he found it. A faint speck, shifting position from one plate to the next, at roughly the distance where a trans-Neptunian planet was expected to be. The world celebrated. A new planet had been discovered, the first since Neptune in 1846. Newspapers ran the story on their front pages. The name Pluto was suggested by an 11-year-old girl in Oxford, England, named Venetia Burney, who thought the Roman god of the underworld suited a world so cold and distant. The name stuck. Pluto took its place in the planetary lineup, the 9th and last, the farthest known world. And there it stayed for decades, quietly orbiting the sun at the edge of the solar system, too small and too far away for telescopes to reveal much detail. We knew it was small. We knew it was cold. We knew its orbit was unusual. But Pluto was a planet, and that was enough. People felt an affection for it that went beyond its scientific importance. It was the underdog of the solar system, the little world that had earned its place against the giants. Then, in August 2006, the International Astronomical Union voted to reclassify it. Pluto was no longer a planet, it was a dwarf planet, a new category created in part because of the discovery of other objects in the Kuiper Belt that were similar in size, including one called Eris that appeared to be slightly more massive than Pluto itself. If Pluto was a planet, then Eris was a planet too, and so were potentially dozens of other icy worlds in the outer solar system. Rather than expand the definition, the International Astronomical Union narrowed it. Pluto was out. The public reaction was immediate and emotional. People protested, they wore shirts, they wrote letters. There was genuine grief, which is a strange thing to feel about a decision on celestial taxonomy, but it reveals how deeply people had attached themselves to the idea of Pluto as a member of the planetary family. The debate has never fully settled, and in certain corners of planetary science, the argument over Pluto's classification continues to this day. But here is the thing. While the world spent 2 decades arguing about whether Pluto deserved to be called a planet, almost no one was paying attention to something far more interesting about what Pluto actually is. Something that had been known since 1978. Something that never really entered the public consciousness the way the demotion did. Something that does not just change how you classify Pluto, it changes how you understand Pluto on a fundamental level. Pluto is not alone out there. It has a companion. And that companion is so large, so close, and so gravitationally significant that it altered Pluto itself. It changed Pluto's rotation. It displaced Pluto's gravitational center. It converted Pluto from a solitary world into one half of a locked pair. 2 frozen bodies circling a shared point in space at the outer edge of the solar system. That companion is called Charon. And the story of how it was found, what it turned out to be, and what its existence means for Pluto, is one of the most quietly extraordinary discoveries in the history of planetary science. On June 22nd, 1978, an astronomer named James Christy was working at the United States Naval Observatory Station in Flagstaff, Arizona, just a few miles from the Lowell Observatory, where Pluto itself had been discovered 48 years earlier. Christy was not looking for a moon. He was doing something much more routine. He was trying to refine the measured position of Pluto on photographic plates that had been taken with the station's telescope about 2 months prior. The plates showed Pluto as a tiny dot of light, barely distinguishable from the background stars. That was normal. Pluto is small and far away. Even through a professional telescope, it does not look like much. But Christy noticed something odd. In some of the images, the dot of light representing Pluto was not round. It was elongated, stretched slightly to one side, as if something were attached to it. A bulge, a bump on one side of the dot that should have been perfectly circular. At first, this might have been nothing. Photographic plates are imperfect. Stars can appear smeared if the telescope tracking drifts slightly, or if atmospheric turbulence distorts the light, or if there is a flaw on the plate itself. But when Christy checked the background stars on the same plates, they were clean, round, sharp, no elongation. Whatever was stretching Pluto's image was not coming from the equipment or the atmosphere. It was coming from Pluto itself. Christy went back to the observatory's archives. He pulled older plates, images taken months and years before, and he found the same anomaly appearing again and again, stretching back to plates from as early as April 1965. The elongation was real, and it was repeating. More importantly, The direction of the bump was changing from plate to plate. It swung around Pluto, shifting position with a regular periodic rhythm. The period was approximately 6.4 Earth days. That was not a plate defect. That was an orbit. Something was circling Pluto, too close and too faint to be resolved as a separate point of light, but large enough to distort Pluto's image into that telltale, elongated shape. Christy and his colleague Robert Harrington analysed the data, confirmed the periodicity, and announced the discovery on July 7th, 1978. Pluto had a moon. The object was initially designated 1978 P1 before receiving its formal name. Christy named it Charon, after the ferryman of the dead in Greek mythology, the figure who carried souls across the river Styx to the underworld, ruled by the god Pluto. There was also a quieter, personal reason for the name. Christy's wife was named Charlene, and her nickname was Char. The name Charon honoured both the mythology and the marriage. It was approved, and it stuck. The discovery itself was important. Pluto had been observed since 1930, nearly half a century, and no one had detected a companion. Now it turned out one had been there the entire time, hiding in the glare of Pluto's own faint light, visible only as a subtle deformation of Pluto's image on photographic plates. That Christy caught it at all was a testament to his careful, methodical approach to the data. He was not looking for a discovery. He was looking for a cleaner orbit solution. But he noticed the anomaly and he did not dismiss it. Yet what made the discovery truly extraordinary was not that Pluto had a moon. Many planets have moons. Mars has 2. Jupiter has dozens. Saturn has more than 100 confirmed natural satellites. What made the discovery extraordinary was what came next. The slow realization, built over years of increasingly precise measurements, of exactly how large Charon actually is. In the years immediately following the discovery, early estimates of Charon's size were rough. Pluto and Charon are so far from Earth and so close together in the sky that separating them cleanly was difficult with the telescopic technology available in the late 1970s. Even the best ground-based telescopes could barely distinguish the two as separate points of light. Charon was there, its orbit was known, its period was measured, but its physical size remained uncertain. Early estimates ranged widely. Some suggested it might be a few hundred kilometers across, a modest icy body caught in Pluto's gravity. Others suspected it was larger, perhaps substantially so, based on how much it brightened and dimmed the combined Pluto-Charon light curve as it moved around its orbit. But no one could say for sure, because no telescope on Earth could resolve the two bodies well enough to measure their individual sizes directly. Then a remarkable stroke of astronomical good fortune arrived. Between 1985 and 1990, Pluto and Charon happened to be oriented so that, as seen from Earth, Charon periodically passed directly in front of Pluto and then behind it. These events are called mutual occultations and transits, and they happen only twice during Pluto's 248-year orbit around the Sun, when the orbital plane of the Pluto-Charon system tilts edge-on toward our line of sight. The previous set of mutual events had occurred in the mid-1800s, long before anyone knew Pluto existed, let alone that it had a moon. The next set would not come until the early 22nd century. This was the only window that any living astronomer would ever see, and the community knew it. Observatories around the world mobilized. Dozens of telescopes, from Hawaii to Chile to South Africa to Australia, were pointed at the faint dot of Pluto-Charon, night after night, over a span of 5 years. The observations had to be carefully timed. Each event, each occultation, and each transit lasted only a few hours. The brightness changes were small, sometimes only a few percent, and had to be measured with high precision against the noise of atmospheric turbulence, instrument drift, and the faintness of the target itself. It was painstaking, methodical work, the kind of science that does not make headlines but quietly builds the foundation for everything that follows. The technique was elegant in its simplicity. When Charon passed in front of Pluto, it blocked a small portion of Pluto's surface from view. The total brightness of the system dipped. The amount of the dip, its depth and duration, depended on the sizes of both bodies, their relative positions, and the reflectivity of the surfaces being blocked. When Charon passed behind Pluto, it disappeared entirely for a time, and the brightness drop told you exactly how much light Charon itself contributed to the system. By modeling these light curves, fitting the observed brightness changes to geometric models of two spheres passing in front of and behind each other, astronomers could extract the diameters of both bodies with the precision that direct imaging could not approach. The method also gave them something else: surface maps. Crude ones, nothing like photographs, but maps of relative brightness across the surfaces of both Pluto and Charon. Because each occultation blocked a different strip of the underlying surface, depending on the geometry of that particular event, the series of events acted like a slow-motion scanner, gradually building up a picture of which parts of each body were brighter and which were darker. For Pluto, these maps revealed something striking. The surface was not uniform. It had bright regions and dark regions, a patchwork of contrast that suggested different surface materials or different ages or both. No one yet knew what those patches were. But they knew Pluto was not a featureless ball of ice. It had a face, a complex, varied surface that no one had seen before. For Charon, the maps were coarser, because Charon is smaller and fainter. But they confirmed that Charon's surface was broadly more uniform than Pluto's, grayer, less contrasty, with fewer dramatic brightness variations. This would later be confirmed spectacularly by New Horizons, but the mutual event observations gave the first hint: two bodies in the same system, orbiting the same sun at the same distance, and they looked fundamentally different from each other. And the sizes that emerged from those painstaking measurements were startling. Charon has a diameter of approximately 1,212 kilometers. Pluto has a diameter of approximately 2,370 kilometers. Stop and sit with those numbers for a moment. Charon is more than half the diameter of Pluto. Not a tenth, not a 20th, not a 100th, more than half. If you place them side by side, they would not look like a planet and its moon. They would look like two worlds, one noticeably larger than the other, but both recognizably substantial. Both round, both real. And diameter, as striking as it is, only tells part of the story. Mass is what matters for gravity, and mass determines how two orbiting bodies interact. Charon's mass is approximately 12% of Pluto's mass, about 1/8. That may sound modest if you hear it in isolation. It is not modest. It is, by the standards of every other major satellite relationship in the solar system, completely unprecedented. Let me show you why. Start with the comparison everyone reaches for first: Earth and the Moon. The Moon is genuinely large as moons go. It has a diameter of about 3,474 kilometers, which makes it bigger than Pluto and the fifth largest moon in the solar system. It is a real world, with craters and mountains and ancient lava plains. But relative to Earth, it is small. The moon's diameter is about 27% of Earth's diameter, and its mass is only about 1.2% of Earth's mass. 1.2%. Earth outweighs the moon by a factor of more than 80. Gravitationally, the moon is a subordinate. It orbits Earth. Earth barely responds. Now consider Jupiter, the giant of the solar system. Jupiter has more than 90 known moons, and its largest, Ganymede, is the biggest moon anywhere in our planetary neighborhood. Ganymede has a diameter of about 5,268 kilometers, which makes it larger than the planet Mercury. If Ganymede orbited the Sun on its own, it would be considered a significant world. But Ganymede does not orbit the Sun on its own. It orbits Jupiter, and Jupiter is so overwhelmingly massive, so gravitationally dominant, that Ganymede constitutes less than 1/100th of 1% of Jupiter's mass. Jupiter has roughly 12,500 times more mass than Ganymede. In terms of gravitational influence, Ganymede is an afterthought. Jupiter could lose Ganymede entirely, and its behavior would barely change. The same pattern holds everywhere you look. Saturn and Titan. Titan is the second largest moon in the solar system, a world with a dense nitrogen atmosphere thicker than Earth's, with rain and rivers and lakes of liquid methane on its surface. Titan is one of the most fascinating places in the solar system, and it constitutes roughly 2/100ths of 1% of Saturn's mass. Saturn is more than 4,000 times heavier. Titan is remarkable. Titan is also gravitationally irrelevant to Saturn's behavior. Neptune and Triton. Triton is the 7th largest moon in the solar system, with a diameter of approximately 2,710 kilometers. It orbits Neptune in a retrograde direction, moving opposite to Neptune's rotation, which strongly suggests it was captured from the Kuiper Belt billions of years ago rather than forming alongside Neptune. Triton is a significant body, but its mass is roughly 2/100ths of 1% of Neptune's mass. Neptune is about 5,000 times more massive. Triton orbits Neptune. Neptune does not respond to Triton in any meaningful way. Mars and its moons tell an even starker story. Phobos is roughly 22 kilometers across. Deimos is about 12. They are small, irregularly shaped, and almost certainly captured asteroids. Compared to Mars, they are specks, grains. Their gravitational influence on Mars is so slight that it is essentially zero. Uranus has 27 known moons. The largest, Titania, has a diameter of about 1,578 kilometers. Substantial in absolute terms, but Uranus is 14.5 times more massive than Earth. Titania's mass is roughly 4,000ths of 1% of Uranus. It does not matter gravitationally. In every single case across the entire solar system, the relationship between a planet and its largest moon follows the same fundamental pattern. The planet is vastly more massive. The moon is a subordinate body. The gravitational center of the system sits comfortably inside the planet. The moon orbits the planet barely moves, every case except one. Charon, 12% of Pluto's mass, more than half its diameter, separated by only about 19,570 kilometers, center to center. For context, the distance between Pluto and Charon is less than the diameter of Neptune. These two worlds are close to each other, close in size, and gravitationally entangled in a way that nothing else in the solar system can match. Think about the comparison directly. The moon is 1.2% of Earth's mass. Charon is 12% of Pluto's mass. That is a tenfold difference in the ratio. The moon is large for a moon. Charon is in a different category entirely. When you hear that Charon is Pluto's moon, your mind automatically assigns roles. Pluto is the important one. Charon is the satellite. Pluto holds. Charon follows. That is what the word moon means in every other context in our solar system. A subordinate body orbiting a dominant one. But Charon does not fit that framework. It is too large, too massive, too close. Its gravitational influence on Pluto is not subtle. It is not a perturbation. It is not a gentle tug that can be ignored in the calculations. It is a fundamental feature of the system. Charon's gravity reaches across the space between the two bodies and affects how Pluto moves, how Pluto rotates, where the gravitational center of the entire system sits. Charon does not politely orbit Pluto from a respectful distance, the way Titan orbits Saturn or Ganymede orbits Jupiter. Charon grabs Pluto. It pulls at Pluto. It reshapes the gravitational architecture of the system in a way that no ordinary moon does to any ordinary planet. And this is the part that most people never learn about Pluto. Not the demotion, not the argument over whether it should be called a planet or a dwarf planet. The truly strange thing about Pluto, the thing that should have dominated every conversation about this world for the last 4 decades, is that Charon is so large relative to Pluto that the system does not behave like a planet with a moon. The gravitational center, the actual balance point of the system, does not sit inside Pluto the way the gravitational center of the Earth-Moon system sits inside the Earth. It sits somewhere else entirely, and that changes everything. It changes how Pluto moves. It changes how Pluto rotates. It changes what Pluto is, in the most literal gravitational sense. Charon did not simply show up and begin circling Pluto like every other moon in the solar system circles its host. Charon arrived, and by its sheer mass and proximity, it converted Pluto from a solitary world with its own independent gravity and rotation into one half of a coupled pair. Two bodies orbiting not each other, not quite, but something in between. A shared point. A gravitational center that belongs to neither world alone. What that point is, where it sits, and why its location matters so profoundly for understanding this system is what we need to examine next. Because once you see where the center of gravity actually falls in the Pluto-Charon system, the word moon stops making sense. And something stranger, something more accurate, begins to take its place. Every object in the universe that orbits another object does not actually circle the center of that other object. That is a simplification. It is the version we teach children because it is easier to draw, easier to picture, and close enough to the truth that it works for most purposes. The moon orbits the Earth. The Earth orbits the sun. The planets trace their ellipses around the star at the center. Simple, clean, and not quite right. What actually happens is that every pair of gravitationally bound objects orbits a shared point between them. That point is called the barycenter. It is the center of mass of the system, the balance point, the location where the gravitational pull of one body on one side is perfectly counterweighted by the gravitational pull of the other body on the other side. Both objects orbit this point, not one orbiting the other, both orbiting the shared center. This is not a technicality. It is not an academic footnote that only matters in the third decimal place of a calculation. It is a fundamental feature of how gravity works, and the location of that barycenter determines the entire character of the relationship between the two objects, whether one body dominates and the other follows, whether both contribute roughly equally, whether the system behaves like a planet with a satellite, or like something else entirely. To understand why the barycenter matters so much for Pluto and Charon, we need to understand where it falls in systems we are more familiar with, and then see what happens when it falls somewhere different. Start with the Earth and the Moon. The Earth has a mass of approximately 5.97 times 10 to the 24th power kilograms. The Moon has a mass of about 7.35 times 10 to the 22nd power kilograms. The distance between their centers is roughly 384,400 kilometers. Using these numbers, you can calculate exactly where the barycenter of the Earth-Moon system lies. The math is straightforward. The barycenter sits on the line connecting the centers of the two bodies at a distance from each that is inversely proportional to their masses. The heavier object is closer to the barycenter. The lighter object is farther away. For the Earth and the Moon, the barycenter falls approximately 4,670 kilometers from the center of the Earth. The Earth's radius is about 6,371 kilometers. So the barycenter sits roughly 1,700 kilometers beneath the surface of the Earth, inside the planet. Comfortably, deeply inside the planet. This is why the Moon appears to orbit the Earth. Technically, both the Earth and the Moon orbit their shared barycenter. But because that barycenter is buried more than 1,000 kilometers below the Earth's surface, the Earth does not appear to orbit anything. It wobbles. It shifts slightly, tracing a small circle around a point that is already inside its own body. The effect is measurable by precise instruments, but to any observer on the surface, the Earth sits still while the Moon goes around it. The common description, the Moon orbits the Earth, is so close to the truth that correcting it feels pedantic. And this pattern holds for every major planet-moon system in the solar system: Jupiter and Ganymede, Saturn and Titan, Uranus and Titania, Neptune and Triton. In every case, the planet is so overwhelmingly massive compared to its largest moon that the barycenter sits deep inside the planet. The moons orbit the planets. The planets wobble imperceptibly. The system behaves exactly the way you expect a planet and moon system to behave. Even Jupiter and the Sun follow a version of this pattern, though with an interesting twist. Jupiter is massive enough, about 1,000th the mass of the Sun, that the barycenter of the Jupiter-Sun system actually lies just barely outside the surface of the Sun. The Sun, in its dance with Jupiter, orbits a point located roughly 742,000 kilometers from its center, which is about 47,000 kilometers beyond the solar surface. This is one of the reasons astronomers can detect Jupiter-like exoplanets around distant stars by measuring the tiny wobble the planet induces in the star's position. But even this case, the only case in our solar system where a barycenter sits outside the more massive body due to a planet's influence on the Sun, involves a mass ratio of roughly 1 to 1,000. Jupiter is huge, but the Sun is 1,000 times heavier. Now consider Pluto and Charon. Pluto's mass is approximately 1.303 times 10 to the 22nd power kilograms. Charon's mass is approximately 1.586 times 10 to the 21st power kilograms. The average distance between their centers is approximately 19,570 kilometers. Run the same barycenter calculation. The barycenter of the Pluto-Charon system falls approximately 2,120 kilometers from the center of Pluto. Pluto's radius is approximately 1,188 kilometers. Do you see it? The barycenter is not inside Pluto. It is not beneath the surface. It is not even at the surface. It is roughly 960 kilometers above Pluto's surface, floating in empty space between the two bodies. Pluto does not contain the center of gravity of its own system. The balance point is out there, in the gap, belonging to neither world. This is not a small distinction. This is the single most important gravitational fact about the Pluto-Charon system, and it is what separates Pluto-Charon from every other planet-moon relationship we know of. When the barycenter sits inside the larger body, the language of planet and moon works. The larger body holds the center. The smaller body goes around. But when the barycenter sits outside both bodies, in the open space between them, neither one holds the center. Both orbit the gap. Both trace paths around a point that exists in the void between them. A point defined by their combined gravity, but contained by neither. Imagine two dancers on a stage, holding hands and spinning. If one dancer is much larger and heavier than the other, the heavy one stays nearly still, while the light one swings wide circles around them. The center of the spin is inside the heavy dancer's body. That is Earth and the Moon. Now imagine two dancers closer in size. Not identical, one is still larger, but the smaller one is substantial. When they hold hands and spin, both of them move. Both trace arcs. The center of the spin sits in the air between their clasped hands, belonging to neither one. Both revolve around it. That is Pluto and Charon. From the outside, if you could watch the Pluto-Charon system from a distance, you would not see a planet sitting still while a moon circles it. You would see two bodies moving. Pluto tracing a small circle around the barycenter. Charon tracing a larger circle around the same point. Both in motion, both responding to the shared center. Both orbiting something that is not the other body, but the invisible balance point of the pair. This is what makes the system a binary, in the gravitational sense of the word. Not because Pluto and Charon are the same size, they are not. Pluto is clearly the larger, the more massive, the primary, but Charon is massive enough and close enough that it has pulled the gravitational center of the system out of Pluto's body entirely. It has displaced the center, moved the fulcrum, forced Pluto to orbit a point in open space, rather than simply sitting at the middle of its own gravitational domain. Every other moon in the solar system lets its planet keep the center. Charon took it away. And the consequences of this are not limited to orbital mechanics. The displaced barycenter is a symptom of something deeper, something that reaches into the rotational behavior of both bodies and produces one of the strangest phenomena in the solar system. Mutual tidal locking. To understand what mutual tidal locking means, you first have to understand what ordinary tidal locking looks like, because it happens all over the solar system, and most people have encountered it without necessarily knowing what it is called. The moon always shows the same face to the Earth. If you have ever looked at the moon on different nights and noticed that the familiar pattern of dark and light patches, the Maria and the Highlands, always appears the same, that is tidal locking. The moon rotates on its axis in exactly the same amount of time it takes to complete one orbit around the Earth, roughly 27.3 days. One rotation equals one orbit. The result is that the same hemisphere of the moon permanently faces the Earth, and the far side permanently faces away. This is not a coincidence. It is the result of tidal forces. The Earth's gravity acts on the moon, but it does not act equally on every part of the moon. The side of the moon facing the Earth is closer to Earth and feels a slightly stronger pull. The far side is farther away and feels a slightly weaker pull. This difference in gravitational force across the body of the moon creates a tidal bulge, a slight elongation of the moon's shape along the Earth-Moon line. If the moon were rotating freely, spinning at a different rate than its orbit, that tidal bulge would be carried out of alignment with the Earth-Moon line by the rotation. But gravity would try to pull the bulge back into alignment, creating a torque, a twisting force that acts to slow the rotation. Over millions of years, this torque gradually slowed the moon's rotation until it matched the orbital period exactly. At that point, the bulge stays aligned. The torque drops to zero. The moon is locked. This same process has tidally locked dozens of moons across the solar system. Most of the large moons of Jupiter and Saturn show the same face to their planets. It is the natural end state for a satellite orbiting close enough to a massive primary. Given enough time, tidal friction wins, and the rotation synchronizes with the orbit. One face toward the planet, always. But there is a crucial asymmetry in ordinary tidal locking. The moon is locked to the Earth, but the Earth is not locked to the moon. The moon raises tides on Earth. You can see them in the oceans. But the Earth is so much more massive than the moon that the tidal braking effect on Earth's rotation is tiny. The Earth's rotation has been slowing very gradually over billions of years, losing approximately 1.4 milliseconds per century due to the moon's tidal influence. Eventually, in the very distant future, the Earth will tidally lock to the moon as well. But that will take tens of billions of years, far longer than the remaining lifespan of the Sun. For now, the Earth rotates freely. The moon is locked, the Earth is not. The relationship is one-directional. Pluto and Charon are different. Because Charon is so massive relative to Pluto, the tidal forces are not one-sided. Charon raises significant tides on Pluto, but Pluto also raises significant tides on Charon, and because the two bodies are so close together, the tidal forces on both sides are strong. Strong enough that over the age of the solar system, approximately 4.5 billion years, both bodies have been braked to a stop. Both have had their rotations slowed until they match the orbital period. The result is mutual tidal locking. Pluto's rotation period, Charon's rotation period, and their shared orbital period are all the same, approximately 6.39 Earth days. Pluto rotates once in 6.39 days. Charon rotates once in 6.39 days, and both complete one orbit around the barycenter in 6.39 days. Everything is synchronized. Everything moves together. The consequence of this triple synchronization is something you have to think about carefully to fully appreciate, because it is unlike anything in ordinary human experience. From the surface of Pluto, Charon does not rise or set. It does not move across the sky. It hangs in one fixed position, always at the same point above the horizon, never drifting left or right, never climbing higher or sinking lower. If you stood on the hemisphere of Pluto that faces Charon, you would see it suspended in the sky permanently, day after day, year after year, century after century. Its apparent size in Pluto's sky would be enormous compared to the Moon in ours, roughly 3.3 degrees across, nearly 7 times the apparent diameter of the full Moon as seen from Earth. A large, grey, round companion, motionless and perpetual, hovering above a landscape of nitrogen, ice, and frozen darkness. And if you walked to the opposite hemisphere of Pluto, the hemisphere that faces away from Charon, you would never see it. Charon would be permanently below the horizon. You could live your entire life on that side of Pluto and never know Charon was there unless someone told you. Two halves of Pluto with completely different skies, one with the permanent companion world overhead, one with nothing but stars and darkness. From Charon's surface, the view is equally strange, but even more dramatic. Pluto, seen from Charon, would appear roughly 7 degrees across, more than 13 times the apparent diameter of the Moon in Earth's sky. It would dominate one entire hemisphere of Charon's sky, a huge, mottled, reddish-beige disk hanging permanently in place, never moving. You could watch its surface features as the two bodies rotate together. The same face of Pluto always showing, always lit at the same angle relative to your position, because you and Pluto are turning in unison. You would see the broad mottled terrain of the Charon-facing hemisphere in permanent detail, though the heart-shaped nitrogen glacier of Sputnik Planitia, sitting on the opposite side of Pluto, would be forever hidden from your view, a feature of Pluto that Charon's side of the sky never reveals. And Pluto would never set, never rise. It would be a permanent fixture, as reliable and as immovable as a mountain. If you were born on the Charon-facing hemisphere of Pluto, or the Pluto-facing hemisphere of Charon, that other world would be part of your sky from your first breath to your last. It would not come and go the way the Moon comes and goes in Earth's sky. It would simply be there, always. This is mutual tidal lock-in. Two worlds that have gravitationally seized each other and frozen each other's rotations. Two worlds that now turn in perfect unison, always showing the same faces, always maintaining the same orientation, always staring at each other across 19,570 kilometers of empty space. There is nothing else like it among the major bodies of the solar system. The Earth and the Moon are half of this picture. The Moon is locked to the Earth, but the Earth still turns freely. From the Moon's perspective, Earth rotates in the sky, cycling through its phases and showing every continent over the course of a day. There is motion in the relationship, change. The view from the Moon's surface shifts hour by hour. Pluto and Charon have no such motion. The dance ended long ago. They reach the final state, the equilibrium, the endpoint of tidal evolution. Both locked, both frozen, both permanent. If nothing disturbs the system, they will remain in this configuration for as long as both bodies exist. Billions of years from now, long after the sun has exhausted its hydrogen fuel and expanded into a red giant, Pluto and Charon will still be out there at the edge of the solar system, locked face to face, circling their shared barycenter in their 6.39-day rhythm, unchanged. There is something profound about the permanence of this arrangement, and we will return to that later. But first, there is another consequence of the barycenter's location that deserves attention, because it extends the double world behavior beyond just Pluto and Charon themselves. Pluto has 4 other known moons besides Charon. They are called Styx, Nix, Kerberos, and Hydra. All 4 are tiny compared to Charon. Styx has an equivalent diameter of about 10.5 kilometers. Nix is roughly 50 kilometers across at its longest dimension. Kerberos is about 19 kilometers long. Hydra is roughly 52 kilometers at its longest. They are small, irregular, icy bodies, more like tumbling fragments and rounded worlds. And they orbit the system in a way that tells you something critical about the gravitational architecture. These 4 moons do not orbit Pluto. They orbit the barycenter, the shared center of mass of the Pluto-Charon system. Their paths circle the same invisible point that Pluto and Charon themselves orbit, the point in empty space between the 2 major bodies. Viewed from above, the system looks like 2 large bodies circling a shared center, with 4 smaller objects tracing wider paths around that same center. The small moons treat the Pluto-Charon pair as if it were a single gravitational source, orbiting the combined system rather than either individual body. This is the behavior you would expect if Pluto and Charon were a binary, 2 gravitationally coupled objects acting as a unified system for any object far enough away. It is the same way that a distant star orbiting a pair of close binary stars does not orbit one star or the other. It orbits the center of mass of the pair. The pair acts as one, and that is exactly what Pluto-Charon does. The orbits of the 4 small moons are nearly circular and nearly coplanar, aligned with the orbital plane of Pluto and Charon. They sit in a remarkably compact arrangement, packed as closely together as orbital stability allows. Their orbital periods are almost exactly in simple ratios with the Pluto-Charon orbital period. Styx orbits in approximately 3.16 times the Pluto-Charon period. Nix in roughly 3.89 times. Kerberos in about 5.04 times. Hydra in approximately 5.98 times. These near-resonant ratios hint at a system that was shaped by the same event that created Charon itself. A system whose architecture carries the fingerprint of its origin. And there is one more detail about these small moons that underscores how unusual the Pluto-Charon gravitational environment is. They tumble. Most moons in the solar system rotate in an orderly way, spinning on their axes with a consistent period, usually tidally locked to their primary, so that the same face always points inward. The 4 small moons of the Pluto-Charon system do not do this. New Horizons observations and earlier Hubble Space Telescope data showed that Nix and Hydra rotate chaotically, tumbling end over end with periods much shorter than their orbital periods, and with orientations that shift unpredictably over time. Styx and Kerberos appear to behave similarly. This happens because of Charon. In a system with a single central body, a small moon in a circular orbit experiences a steady tidal field. It can lock into a stable rotation. But in the Pluto-Charon system, the small moons are orbiting 2 massive bodies that are themselves orbiting each other. The gravitational field they experience is not steady. It fluctuates as Pluto and Charon move around the barycenter, creating a constantly shifting tidal environment that prevents the small moons from settling into a stable rotation state. They are caught in the gravitational crossfire of a binary system, and the result is perpetual chaos. This chaotic tumbling is a direct consequence of the Pluto-Charon mass ratio. If Charon were smaller, if it were a typical moon with a mass of a fraction of 1% of Pluto, the gravitational environment around the system would be dominated entirely by Pluto. The small moons would feel essentially one gravitational source and would lock tidally in the usual way. But Charon is not a typical moon. It is 12% of Pluto. It contributes significantly to the gravitational field of the system, and that contribution is enough to destabilize the rotation of every small body in the system's neighborhood. Even the small moons of the Pluto system are telling you, through their tumbling, that Charon is not an ordinary satellite. The whole system behaves differently because Charon is there. Let me summarize what the barycenter, the mutual lock, and the circumbinary moons collectively tell us about the Pluto-Charon system, because taken together they paint a picture that the word moon simply cannot contain. The gravitational center of the system sits outside both bodies in empty space. Both bodies orbit that shared center, each tracing its own path, neither one sitting still. Both bodies are tidally locked to each other, permanently facing the same hemispheres toward each other, rotating and orbiting in perfect synchronization at 6.39 days. The 4 smaller moons orbit the system's barycenter, not Pluto alone, treating the pair as a single gravitational entity. Those small moons tumble chaotically because the gravitational field of the system is dominated by 2 large bodies, not one. No other planet-moon system in our solar system has all of these characteristics. No other system has any of them, except the barycenter being inside the primary, which every other system maintains. Pluto-Charon breaks the pattern at every level. This is why planetary scientists have, for decades, referred to Pluto-Charon as a binary system, a double dwarf planet, a double world. Not officially. The International Astronomical Union has never formally defined what constitutes a binary planet or double planet, and Charon remains classified as a moon of Pluto in every official catalogue. But the gravitational reality does not care about catalogues. The gravitational reality says that Pluto does not hold its center, that Charon is not a subordinate, that the 2 bodies orbit together around a shared point that neither contains, that the system, in its architecture and its behavior and its dynamics, is a pair. And there is something else that the gravitational analysis alone does not tell you. Something that you can only learn by going there and looking. Because for all the calculations and orbital models and theoretical frameworks that have been applied to the Pluto-Charon system since 1978, for all the decades of telescopic observation and mathematical analysis, the system remained abstract until one spacecraft made the journey. Until one set of cameras flew close enough to turn those orbital diagrams into real places, real landscapes, real geology, real worlds with surfaces scarred by histories we did not expect. What those cameras found when they reached Charon, what was waiting on the surface of this supposedly inert ball of ice when the first close-up images arrived on Earth, changed how we understood not just the system's dynamics, but its history. Because Charon is not a featureless companion. It is a world, and it has been through something violent. For 37 years after James Christy discovered it, Charon remained a smudge, a bump on a photographic plate, a name attached to orbital calculations, a dot of light next to a slightly larger dot of light, the 2 of them too close together and too far from Earth for any telescope to separate into detailed images. The Hubble Space Telescope, launched in 1990, could resolve Pluto and Charon as distinct points. It could measure their brightness independently. It could confirm their sizes and their orbital parameters. But it could not show you what Charon looked like. It could not reveal terrain, or features, or color, or geology. Charon was real. It was measured. It was known to exist with absolute certainty. But it was not yet a place. That changed because of a spacecraft called New Horizons. And the story of how it got there is itself worth pausing on, because the scale of the effort reveals how much was riding on a single afternoon at the edge of the solar system. New Horizons launched on January 19th, 2006, from Cape Canaveral, Florida, aboard an Atlas V rocket. At the time of launch, it was the fastest spacecraft ever sent from Earth, leaving the planet at a velocity of roughly 58,500 kilometers per hour. It passed the orbit of the Moon in just 9 hours. For comparison, the Apollo missions took about 3 days to cover that same distance. New Horizons was in a hurry, and it needed to be. Its destination was nearly 5 billion kilometers away, and even at that extraordinary speed, the journey would take almost a decade. The spacecraft itself was compact, about the size and shape of a grand piano, roughly 2.2 meters across, carrying 7 scientific instruments packed into a payload that weighed less than 30 kilograms. It had no braking engine. There was no plan to slow down, enter orbit, or land. The entire mission was built around a single concept: get to Pluto as fast as physically possible, collect as much data as you can during the flyby, and transmit it home before you disappear into the outer solar system forever. One pass, one chance. Everything depended on the spacecraft executing its observation sequence autonomously, because the distance was so great that a radio signal from Earth took 4.5 hours to reach the spacecraft. If something went wrong at closest approach, the mission controllers would not even know about it for hours, let alone have time to send a correction. New Horizons had to run this encounter on its own. 13 months after launch, New Horizons swung past Jupiter, using the giant planet's gravity to pick up an additional 14,000 kilometers per hour of speed. That gravity assist shaved roughly 3 years off the journey. Then, the spacecraft settled into what its team called the long cruise, years of quiet flight through the outer solar system. Most of its instruments powered down to conserve energy, the onboard computer maintaining course and orientation while Earth grew steadily fainter behind it. The long cruise lasted more than 8 years. For most of that time, New Horizons was essentially dormant, waking periodically for systems checks, course corrections, and instrument calibrations, then going quiet again. The team on the ground monitored it, maintained communication, planned the encounter in ever-increasing detail, but there was nothing to see. Just the black of deep space and the slow, steady approach to a world that no spacecraft had ever visited. By the beginning of 2015, New Horizons was close enough to begin its approach observations. Pluto and Charon resolved from points of light into small disks. Distinct colors became visible. Pluto appeared warm-toned, a mottled pinkish beige. Charon was cooler, grayer. For the first time in the history of astronomy, these two worlds had faces. Not just orbital parameters, not just light curve data, actual visible surfaces with markings and variations and contrast. Then came July 14th, 2015, the day of closest approach. New Horizons flew through the Pluto system at approximately 49,700 kilometers per hour, passing roughly 12,500 kilometers from Pluto's surface and about 29,000 kilometers from Charon. The encounter window, the period of closest approach when the most detailed observations could be made, lasted only a few hours. During that window, every instrument on the spacecraft fired at maximum capacity, filling its onboard solid-state data recorders with images, spectra, particle measurements, and radio science data. The spacecraft could not transmit and observe at the same time, so it fell silent during the encounter, storing everything internally. For almost 22 hours around closest approach, Earth heard nothing from New Horizons. The team waited. Late on the evening of July 14th, Eastern Time, the spacecraft turned its antenna back toward Earth and sent a brief status signal. The data had been collected. The instruments had worked. The flyby was a success. The team at the Johns Hopkins Applied Physics Laboratory erupted. 9.5 years of flight, 5 billion kilometers of travel, and the gamble had paid off. But the data itself took much longer to arrive. New Horizons' transmitter operated at roughly 12 watts, about the power of a refrigerator light bulb, pushing a signal across 4.6 billion kilometers of space. The data rate was agonizingly slow, roughly 1 to 2 kilobits per second. At that rate, it took more than 16 months to fully transmit all of the flyby data back to Earth. The images came in batches, the best ones first, then progressively more data filling in the details. Every few days or weeks, new images appeared that no human being had ever seen before, and what they showed was not what anyone had expected. Start with what scientists thought they would find on Charon. Before New Horizons, the prevailing assumption about Charon was that it would be geologically dead, cold, old, heavily cratered, and featureless. This was not an unreasonable expectation. Charon is small. Its diameter of roughly 1,212 kilometers puts it in a size class where most bodies in the solar system have long since exhausted their internal heat and gone quiet. Small bodies cool faster than large ones. They have less radioactive material to generate heat. They have less gravitational energy from formation. Without an internal heat source, there is no geological activity, no volcanism, no tectonics, no resurfacing. The surface simply accumulates craters over billions of years, becoming more and more battered until it looks like every other dead, ancient ice ball in the outer solar system. That is what they expected. A battered, frozen relic. What they got was something completely different. The first high-resolution images of Charon showed a world that had been torn open. Across the middle of Charon's Pluto-facing hemisphere, cutting roughly east to west, runs a vast system of canyons and tectonic faults. This feature, informally named Serenity Chasma, after the fictional spaceship from the television series Firefly, stretches for more than 1,600 kilometers. That is a rift system long enough to wrap more than a third of the way around Charon's entire circumference. Longer than the Grand Canyon system on Earth. Longer than the East African Rift. Longer than any comparable feature on any moon of comparable size that we have ever observed. And the depths are staggering. Individual chasms within the system reach 5 to 7 kilometers deep. The largest single trough, Pluto-Charon, located in the far north, plunges approximately 13 kilometers into the surface, more than 7 times the depth of Earth's Grand Canyon. These are not gentle valleys. They are not the slow signatures of gradual erosion or quiet subsidence. They are fractures, faults, places where the crust of Charon was pulled apart by forces strong enough to crack an entire world. If you could stand at the rim of Pluto-Charon and look down, the opposite wall would be so far away and so deep that the floor of the canyon would be lost in shadow, a slash of blackness carved into grey-white ice under the dim, red-shifted light of the distant sun. The canyon system effectively divides Charon into 2 distinct geological provinces, A rugged, cratered northern terrain informally called Ozterra, and a smoother southern plain, as if something seized the moon and pulled it in opposite directions until the surface split. South of the Great Canyon system lies the region the New Horizons team informally named Vulcan Planitia, a broad, relatively smooth plain that stands in sharp contrast to the battered terrain to the north. Vulcan Planitia has fewer craters than the Northern Highlands, which means its surface is younger. Something resurfaced it. Something flooded that region with material that buried the older, more heavily cratered landscape beneath a fresh layer. Within Vulcan Planitia, the New Horizons cameras also captured features that the science team called moated mountains. Isolated peaks rising from the plain with troughs or depressions encircling their bases, as if the mountains were sinking slowly into a once soft surface that later refroze around them. These features have no precise analogue elsewhere in the solar system. They are unique to Charon, and they hint at a period in this world's history when the southern hemisphere was not a solid plain, but something closer to a viscous slush, warm enough to deform, cold enough to preserve the mountains that sank partway into it before the whole surface locked solid. The best explanation for all of this, supported by the topographic and geological evidence in the New Horizons data, is cryovolcanism. Not volcanism in the earthly sense of molten rock erupting from beneath the ground, but the outer solar system equivalent. Flows of liquid or slushy water, possibly mixed with ammonia and other volatiles, erupting from beneath Charon's icy crust and spreading across the surface before freezing solid. The flows filled in craters, smoothed the terrain, and created a plain that looks strikingly similar to the volcanic Maria on Earth's moon. The dark, flat regions that ancient astronomers mistook for seas. For this to happen, Charon needed liquid water beneath its surface. It needed an internal ocean, or at least pockets of liquid water held in a warm interior, at some point in its past. And that is itself a remarkable conclusion for a body this small and this far from the sun. Charon should have frozen solid relatively early in solar system history. The fact that it apparently retained enough internal heat to drive cryovolcanic resurfacing tells you that something unusual happened to this world. Something that injected energy into its interior, warming it from within, keeping it geologically active longer than its size alone would predict. And then there is the relationship between the canyon system and the freezing ocean. The leading geological interpretation is that the canyons formed when Charon's subsurface ocean finally froze. Water expands when it freezes, unlike most substances, by about 9% in volume. An ocean of liquid water beneath Charon's icy shell, gradually freezing over hundreds of millions of years, would have expanded as it solidified, pushing outward against the rigid crust above it. That crust could not stretch to accommodate the expansion. So it broke. The great rift system that divides Charon's hemisphere is, in this interpretation, the scar left by a world splitting at the seams as its interior froze and swelled. The canyon system is not a sign of collapse or contraction. It is a sign of expansion. Charon cracked because its insides grew. We will return to what supplied the heat for that interior ocean in a moment. But first, there is one more surface feature that demands attention, because it is one of the most visually arresting discoveries New Horizons made anywhere in the Pluto system. Charon's North Pole is red, not subtly tinted, not faintly discolored, distinctly, unmistakably red. A large, dark, reddish-brown cap covering the polar region above approximately 70 degrees north latitude, centered on the pole and spreading outward in an irregular patch with a dark core roughly 375 kilometers across. The New Horizons team named it Mordor Macula, after the Dark Realm in Tolkien's The Lord of the Rings. The name is informal, but it suits the feature. Mordor Macula looks ominous. It looks stained. Against the pale grey water ice surface of the rest of Charon, it looks like something was spilled. Something was spilled, in a sense. The reddish material is made of organic compounds called tholins. Tholins are complex carbon-based molecules, sticky hydrocarbon residues formed when simpler molecules like methane and nitrogen are broken apart by radiation and then recombine into heavier, more complex chains. The word organic here does not mean biological. Tholins are produced by chemistry, not life, but they are common in the outer solar system. They give many Kuiper Belt objects their reddish coloration. And the tholins on Charon appear to have a specific source. Pluto has a thin atmosphere, mostly nitrogen with traces of methane and carbon monoxide. That atmosphere is tenuous, with a surface pressure roughly 100,000 times lower than Earth's, but it is real and it is active. Methane molecules in Pluto's atmosphere can escape into space, particularly during the warmer portions of Pluto's 248-year orbit, when the atmosphere expands slightly. Some of that escaping methane drifts outward and reaches Charon. At Charon's poles, where temperatures drop to some of the coldest values in the system during the long polar winter, that methane freezes out of the near vacuum and deposits on the surface as a thin frost. Once deposited, the methane frost is exposed to ultraviolet radiation. Not from the sun directly, which is far too distant to provide intense ultraviolet flux at Pluto's distance, but from the Lyman alpha glow, a diffuse ultraviolet light scattered by hydrogen atoms in the interplanetary medium that permeates the entire solar system. This faint but persistent radiation breaks apart the methane molecules over time, and the fragments recombine into heavier hydrocarbons. Those hydrocarbons are further processed into tholins, the dark reddish compounds that accumulate on the pole season after season, building up over millions of years into the stain that New Horizons photographed. There is also an alternative hypothesis, published in 2022 by researchers at Purdue University, suggesting that the methane source might be endogenic rather than atmospheric. In this model, the methane came from Charon's own interior, erupted through ancient cryovolcanoes during the period when Charon still had internal heat, and migrated to the poles where it was cold trapped and processed into tholins by the same radiation mechanism. This model connects Mordor Macula to the cryovolcanic resurfacing of Vulcan Planitia, suggesting that the same period of internal activity that resurfaced the southern plains also supplied the methane that eventually became the red polar cap. Either way, the result is the same. Charon wears a crown of organic chemistry at its north pole, a visible record of molecular exchange between Pluto and Charon, or between Charon's interior and its surface, painted in rust-colored compounds over billions of years. New Horizons confirmed that the South Pole shows similar dark reddish material, seen only faintly by light reflected from Pluto onto Charon's winter hemisphere. Both poles are stained. The process operates on both ends. Taken together, the canyons, the resurfaced plains, the moated mountains, and the red polar cap tell you that Charon is not a dead world. It was active. It had an interior warm enough to drive geology. It has a surface shaped by forces that are not simply the passive accumulation of craters over time. It is a world with a history, and that history is violent. Which brings us to the question that has occupied planetary scientists since the 1980s, sharpened by every new piece of data from New Horizons, and given a striking new answer in January 2025. How did Charon form? The question is important because Charon's size and orbital characteristics are extremely difficult to explain through any of the ordinary formation mechanisms that account for other moons. There are 3 standard ways to make a moon: capture an existing body gravitationally, co-accrete alongside the planet from the same cloud of material during the planet's formation, or form from debris ejected in a giant impact. Capture is the easiest to picture. A body drifting through space passes close to a planet, loses enough energy through some dissipative process, and falls into orbit. This is how Triton likely became a moon of Neptune. It was a Kuiper Belt object that wandered too close and was gravitationally seized. But capture has a fundamental difficulty when it comes to Charon. Captured moons tend to end up on eccentric, inclined, or retrograde orbits. Triton's retrograde orbit is the classic signature. Charon's orbit is circular, coplanar with Pluto's equator, and prograde. It shows none of the hallmarks of capture. More importantly, capture requires the incoming body to lose energy somehow. And for a body as massive as Charon, the amount of energy that would need to be dissipated during a single encounter is enormous. Gravitational capture of a body 12% of the primary's mass into a clean circular orbit is dynamically almost impossible without some extraordinary additional mechanism. Co-accretion, where Pluto and Charon form together from the same region of the protoplanetary disk, can explain the coplanar circular orbit, but it has its own problems. Co-accreting bodies tend to have similar compositions and densities, which Pluto and Charon roughly do, both being a mix of rock and ice with densities of approximately 1.85 and 1.70 grams per cubic centimeter, respectively. But co-accretion struggles to explain the enormous angular momentum of the system. The Pluto-Charon pair has far more angular momentum, more rotational energy in their mutual orbit, than you would expect from 2 bodies that simply condense side by side out of a slowly rotating cloud. Something had to inject that energy. That something, in the leading hypothesis, was a giant impact. The idea was first proposed in the 1980s by William McKinnon and later developed through detailed hydrodynamic simulations by Robin Canup at the Southwest Research Institute, published in 2005. The scenario is directly analogous to the leading theory for the origin of Earth's moon. In the Earth-Moon case, a Mars-sized body called Theia struck the young Earth roughly 4.5 billion years ago. The impact was so violent that it partially melted both bodies, ejecting a vast cloud of molten debris into orbit around the Earth, which subsequently coalesced into the moon. The Pluto-Charon version posits that a similar event occurred in the early Kuiper Belt. A large body, roughly comparable in size to the original Pluto, struck Proto-Pluto in a glancing collision. The impact was energetic enough to eject material into orbit, or to partially destroy the impactor and leave a large remnant gravitationally bound to Pluto. That remnant, or the body that accreted from the debris, became Charon. Canup's 2005 simulations showed that this scenario was plausible. Under the right impact conditions, a glancing blow at relatively low velocity, the collision could produce a system with the correct mass ratio, the correct angular momentum, and the correct orbital separation. Importantly, the simulation suggested that Charon likely survived the impact largely intact, rather than being assembled from a disk of scattered debris the way Earth's moon is thought to have been. This intact capture outcome was favored because it naturally preserved the density similarity between Pluto and Charon. In scenarios where Charon formed from a debris disk, the reaccretion process tends to preferentially incorporate ice over rock, producing a satellite with a lower density than the primary. Charon's density is close to Pluto's, consistent with an intact or nearly intact impactor, rather than a reconstituted debris pile. The giant impact model also explained the system's angular momentum. A collision between two roughly 1,000-kilometer class objects at the right angle and velocity naturally imparts the angular momentum observed in the Pluto-Charon orbit. It explained why the orbit is circular and coplanar, because tidal evolution after the impact would circularize any initial eccentricity and align the orbital plane with the rotational equator. And it provided the energy source for Charon's geological activity. A giant impact injects enormous thermal energy into both bodies. Both Pluto and Charon would have been substantially heated, potentially forming subsurface oceans that persisted for hundreds of millions of years before freezing. The expansion of that freezing ocean could have cracked Charon's crust, creating the vast canyon system that New Horizons revealed. For 20 years, the giant impact model was the accepted framework. The details were debated, the specific collision parameters were refined, and alternative scenarios were explored. But the basic story held. Two large icy bodies collided in the early Kuiper Belt. One became Pluto, one became Charon. The impact bound them together. Then, in January 2025, a study published in Nature Geoscience challenged a fundamental assumption of that story. The study was led by Adine Denton, a NASA postdoctoral fellow who conducted the research at the University of Arizona's Lunar and Planetary Laboratory and the Southwest Research Institute. Denton and her colleagues, including senior author Eric Asfog, had done something that previous impact modelers had not. They included material strength. Previous simulations of the Pluto-Charon forming impact had treated both bodies as if they were fluids. This is standard practice in giant impact modeling. When two planet-sized objects collide at high speed, the energies involved are so enormous that rock and ice behave like liquids. They deform, flow, splash, and merge. The fluid approximation works well for collisions between large, warm bodies like the early Earth and Theia, where the internal temperatures are high enough that the materials genuinely do behave as fluids during the impact. But Pluto and Charon are different. They are smaller. They are colder. They are made of rock and ice at temperatures far below the melting points of either material. Denton's team argued that at these temperatures and sizes, the structural strength of the materials matters. Rock and ice in the outer solar system are rigid. They resist deformation. They do not behave like fluids when struck. They behave like solids, at least partially, and that changes the dynamics of the collision. When Denton's team ran their simulations with material strength included, the outcome was dramatically different from the classical fluid models. Instead of the impactor being destroyed or heavily deformed and then captured into orbit, something unexpected happened. The two bodies collided, compressed against each other, and stuck together. They formed a single elongated structure like a cosmic snowman, two roughly spherical bodies joined at a contact point. They rotated together as one object for a brief period, and then, because of the angular momentum of the collision and the rigidity of the materials, they separated. The contact point broke. The two bodies pulled apart, but they did not fly away from each other. They remained gravitationally bound, settling into orbit around their shared barycenter. Denton called it kiss and capture. The two worlds kissed, touching and briefly merging, then pulled apart while remaining locked together by gravity. It is a type of collision outcome that had never been described before in the literature of planetary impact dynamics. And it has remarkable properties. First, kiss and capture naturally produces the correct orbit. The parameters that allow the two bodies to temporarily merge and then separate are the same parameters that place the resulting satellite in a stable orbit with the right separation and angular momentum. As Asphalt put it, you get two things right for the price of one: the capture itself and the correct orbital properties, without having to fine-tune the impact conditions. Second, kiss and capture preserves both bodies. In the classical giant impact model, even in the intact capture scenarios, the impactor and the target undergo significant deformation. Material is exchanged, surfaces are melted, internal structures are disrupted. In kiss and capture, both Pluto and Charon remain largely intact. Their original compositions, their internal layering, their bulk properties are mostly preserved through the collision. This could explain why Pluto and Charon have such similar densities. They did not mix. They did not exchange material extensively. They bumped, stuck, spun, and separated. Third, and this connects directly to the geological evidence from New Horizons, kiss and capture provides a natural explanation for the heat that drove Charon's geological activity. The collision itself deposits thermal energy in both bodies, particularly at and near the contact region. And after separation, as Charon moved outward to its current orbital distance through tidal evolution, tidal heating provided an additional sustained energy source. The combination of impact heating and subsequent tidal heating could have maintained Charon's interior warm enough for a subsurface ocean to persist for a geologically significant period, long enough to drive the cryovolcanic resurfacing of Vulcan Planitia and the fracturing that created the Great Canyon system. Denton's study also addressed a problem that had quietly troubled modelers of Pluto's geology. Some earlier work had suggested that if Pluto formed warm enough for the giant impact to work in the traditional fluid model, its surface should display contractional features, wrinkle ridges, and compressional faults that form when a warm body cools and shrinks. New Horizons did not see those features on Pluto. Kiss and capture resolves this. If Pluto started cold and solid, which the material strength simulations require, then it would not have had those contractional features in the first place. The heat came later, from the impact and from tidal evolution, and the resurfacing that followed could have buried any early forming features beneath fresh material. It is important to state clearly that the kiss and capture model is new. It was published in January 2025. It has not yet been tested against every constraint that the Pluto-Charon system provides, and further simulations and analyses will be needed to determine whether it fully replaces the classical giant impact scenario or represents one end of a spectrum of possible outcomes. The classical model is not dead. Canup's original work remains scientifically sound, and it is possible that the actual formation event fell somewhere between the fully fluid and fully rigid end members. But Denton's work introduces a fundamentally new possibility, one that better accounts for the material properties of cold, icy outer solar system bodies, and it demonstrates that the formation of Charon was even stranger than previously thought. What both models agree on, and what the geological evidence from A New Horizons strongly supports, is that the Pluto-Charon system was born in violence. Two large icy worlds, drifting through the early Kuiper Belt in the chaotic aftermath of planetary migration, found each other. They collided. And from that collision, rather than destruction, a partnership emerged. Two bodies, bound together by gravity, settling into their mutual orbit, tidally evolving toward the locked, synchronized state we observe today. The impact that created the system also shaped the surfaces we see. Charon's Great Canyon system, its resurfaced plains, its red polar caps, all of these are downstream consequences of the event that brought the two worlds together. Charon is not a captured drifter. It is not a co-formed sibling that grew up beside Pluto in the primordial disk. It is the product of a collision, a body that was forged or preserved in the most violent event in Pluto's history, and then gravitationally chained to Pluto for the rest of time. The impact gave Pluto a partner, tidal forces locked the partnership in place, and New Horizons showed us the scars. There is one more detail from the flyby data that deserves mention, because it connects the surface geology of Charon back to the gravitational relationship we examined earlier and forward to a larger context that we have not yet explored. Charon's surface is dominated by water ice. Spectral measurements from New Horizons confirm that the majority of the surface material is water ice, with trace amounts of ammonia-bearing compounds detected in some regions, particularly associated with fresh-looking craters. This is in stark contrast to Pluto, whose surface is covered primarily in nitrogen ice, methane ice, and carbon monoxide ice, exotic volatiles that are absent from Charon's surface. The compositional difference matters because it tells you that despite their proximity, despite being locked together face to face for billions of years, Pluto and Charon have remained chemically distinct worlds. They share a gravitational center. They share an orbital period. They share a tidal lock. But they do not share a surface chemistry. Pluto kept its volatiles. Charon lost its, if it ever had much to begin with. The methane that reaches Charon from Pluto's atmosphere is a thin seasonal deposit, not a permanent surface feature. Beneath that transient frost, Charon's surface is water ice, clean and ancient and fundamentally different from the nitrogen-rich landscape of its partner. Two worlds, locked together, staring at each other. And yet, chemically, they remain strangers. Pluto, coated in exotic ices, geologically active with glacial flows and atmospheric cycles. Charon, armored in water ice, scarred by ancient tectonics and resurfacing, wearing a cap of borrowed and processed methane at its poles. They are not twins. They are not copies of each other. They are two distinct worlds, each with its own character, its own history, its own surface story, bound into a gravitational relationship that makes them inseparable but does not make them the same. And that, perhaps, is the most important thing that New Horizons taught us about Charon. It is not just a gravitational curiosity. It is not just an orbital anomaly. It is a place, a world with canyons deeper than anything on Earth, with plains resurfaced by ancient ice eruptions, with mountains sinking into once soft ground, with a red polar cap painted by organic chemistry over millions of years, with a composition that tells its own story separate from the story of Pluto, It earned its place in the system not just by its mass, but by its complexity. The question that remains is what all of this means, not just for the Pluto-Charon system, but for the outer solar system as a whole. Because Pluto and Charon are not floating in isolation. They are members of a population, one binary pair among potentially many, in a vast, cold, dimly lit region of space that stretches far beyond Neptune's orbit. And the existence of this one double world at the edge of the solar system raises a possibility that is both humbling and exciting. They might not be the only ones. The Pluto-Charon system does not exist in isolation. It orbits the Sun at an average distance of roughly 5.9 billion kilometers, in a region of the solar system called the Kuiper Belt. And to understand what the Pluto-Charon double world means, you have to understand where it lives and why it has survived there for so long. The Kuiper Belt is a vast ring of icy bodies extending from roughly the orbit of Neptune, at about 30 astronomical units from the Sun, outward to approximately 50 astronomical units, and possibly beyond. 1 astronomical unit is the distance from the Earth to the Sun, about 150 million kilometers. So the Kuiper Belt begins roughly 4.5 billion kilometers from the Sun and stretches outward for billions of kilometers more. A broad, flat, cold zone populated by remnants from the formation of the solar system. Pluto orbits within this zone, but its orbit is not simple. It is highly elliptical, tilted at 17 degrees to the plane of the other planets, and it crosses inside the orbit of Neptune for roughly 20 years out of every 248-year lap around the Sun. That crossing might seem dangerous. Neptune is an ice giant roughly 17 times more massive than Earth, and any close encounter with a body that large would be catastrophic for the Pluto-Charon system. The tidal forces from a near pass could disrupt the binary, strip away the small moons, or eject Pluto from its orbit entirely. The fact that Pluto and Charon have survived, undisturbed, for 4.5 billion years despite sharing orbital territory with Neptune demands an explanation. The explanation is a gravitational safeguard called a mean motion resonance. Pluto is locked into a 3-to-2 resonance with Neptune, meaning that for every 3 orbits Neptune completes around the Sun, Pluto completes exactly 2. This is not an approximation. It is a precise gravitational relationship, maintained over billions of years by the same tidal and gravitational forces that shaped the early solar system. Neptune orbits the Sun roughly once every 165 years. Pluto orbits roughly once every 248 years. 3 Neptune orbits take about 495 years. 2 Pluto orbits take about 496 years. The match is almost exact and the resonance keeps it locked. The consequence of this resonance is that Pluto and Neptune never come close to each other. When Pluto crosses inside Neptune's orbital distance, Neptune is always on the far side of the solar system, billions of kilometers away. The choreography repeats with every cycle. Pluto dips inward. Neptune is elsewhere. Pluto swings back outward. Neptune returns, but by then, Pluto has moved on. The two never meet. They cannot meet because the resonance prevents it. It is as if the solar system built a scheduling rule into their orbits. You may share the same road, but you may never be on the same stretch at the same time. This resonance was not always in place. It was established early in solar system history, roughly 4 billion years ago, when Neptune migrated outward from its formation location closer to the Sun. As Neptune moved outward through the primordial Kuiper Belt, its gravity swept up, scattered, and rearranged the icy bodies in its path. Some were flung into the inner solar system, some were ejected entirely, and some, including Pluto, were captured into resonant orbits, gravitationally herded into orbital periods that kept them safely synchronized with Neptune's motion. Once captured, the resonance is self-reinforcing. Small perturbations that would push Pluto out of the resonance are corrected by gravitational interactions with Neptune that nudge it back into the locked rhythm. The system is stable. It has been stable for billions of years, and it will remain stable for billions more. This matters for the Pluto-Charon double world because it means the partnership is protected, not just by the sparseness of the Kuiper Belt and the rarity of close encounters with other small bodies, but by the architecture of the solar system itself. Neptune, the nearest giant planet, the only body massive enough to pose a genuine threat, is permanently kept at a distance by the resonance. The double world at the edge is not just surviving by chance. It is surviving because the gravitational structure of the outer solar system has been keeping it safe since before life appeared on Earth. These remnants populating the Kuiper Belt are not leftovers in the sense of debris. They are original material. Pieces of the protoplanetary disk that never assembled into a planet because Neptune's gravitational influence stirred the region too violently for large bodies to finish forming. The Kuiper Belt is a fossil bed. Its objects carry chemical and physical information about the conditions that existed in the outer solar system 4.5 billion years ago, before the planets settled into their current orbits, before Neptune migrated outward and scattered the disk, before the architecture of the solar system reached the relatively stable configuration we observe today. And there are a lot of them. Astronomers estimate that the Kuiper Belt contains hundreds of thousands of objects larger than 100 kilometers in diameter, and possibly trillions of smaller ones. The largest known Kuiper Belt objects, besides Pluto itself, include Eris, which is slightly more massive than Pluto, though slightly smaller in diameter, Haumea, an elongated, rapidly spinning body with 2 small moons, Marke, a reddish world roughly 3/5 the diameter of Pluto, and Gong, a body roughly 1,250 kilometers across with its own moon. These are substantial worlds, round or nearly round, large enough for gravity to have pulled them into spherical shapes, carrying their own surface chemistries and geological histories, and many of them have companions. This is the detail that transforms the Pluto-Charon story from a single curiosity into something with broader implications. Binary systems are not rare in the Kuiper Belt. They are surprisingly common. Surveys of Kuiper Belt objects have revealed that a significant fraction, estimates range from roughly 10 to 30% depending on the population surveyed and the detection limits, are binaries. 2 bodies orbiting a shared center of mass. Some of these are large primary bodies with small satellites, similar to the planet-moon relationships familiar from the inner solar system, but others are closer in character to Pluto-Charon. Pairs where the secondary body is a substantial fraction of the primary's mass. Pairs where the barycenter might lie between the 2 objects, rather than inside either one. Pairs that look less like a world with a satellite, and more like 2 worlds bound together. Eris has a moon called Dysnomia. Dysnomia is much smaller than Eris, with a diameter of roughly 700 kilometers compared to Eris's approximately 2,326 kilometers. But recent studies suggest its mass ratio to Eris could be high enough to make it dynamically significant, and its formation may involve the same kind of giant impact process that created Charon. Haumea has two moons, Hi'iaka and Namaka, and its rapid rotation and elongated shape suggest it was involved in a major collision that may also have produced a family of smaller icy fragments, sharing its orbit. Quaoar, roughly 1,110 kilometers in diameter, has a small moon called Weywot. Orcus has Vanth, Vardar has Ilmarae, Salacia has Actaea. The outer solar system is full of partnerships. Not all of these are double worlds in the way Pluto-Charon is a double world. Most have mass ratios far less extreme than Pluto-Charon's. But the prevalence of binary systems in the Kuiper Belt tells you something important about the environment in which these objects formed. The early outer solar system was not a place where solitary objects drifted in splendid isolation. It was a place where collisions happened, where bodies interacted gravitationally, where the conditions existed for objects to become paired, whether through impacts, through gravitational capture during close encounters in a denser primordial disk, or through a process called gravitational collapse of pebble clouds, in which two bodies formed simultaneously from the same collapsing cloud of material and end up in mutual orbit from the moment of their creation. The last mechanism is particularly interesting because it has been proposed as an explanation for a specific class of Kuiper Belt binaries, the so-called cold classical objects. These are Kuiper Belt objects on nearly circular, low-inclination orbits in the outer part of the belt. A population that appears to have remained relatively undisturbed since the early solar system. Among the cold classicals, the binary fraction is remarkably high, possibly 40% or more. And the binaries in this population tend to have similar-sized components, with mass ratios much closer to 1-to-1 than the typical planet-moon relationship. They look like pairs of objects that formed together rather than pairs created by later collisions. Arakoth, the small Kuiper Belt object visited by New Horizons in January 2019 after its Pluto flyby, is a contact binary. Two lobes join together in a snowman-like shape, roughly 33 kilometers long. Arakoth is thought to have formed through the gentle gravitational collapse of a rotating cloud of pebbles in the protoplanetary disk, with the two lobes representing two concentrations within that cloud that came together at low velocity and stuck. It never separated. It never became a binary in orbit, but it represents the same fundamental tendency of the outer solar system to produce paired structures. The point is this: the Pluto-Charon system is not a freak. It is not a one-off accident. It is an extreme example of a phenomenon that appears to be common in the Kuiper Belt. The formation of paired bodies, gravitational partnerships, systems where two objects are bound together and interact dynamically in ways that single, isolated objects do not. Pluto-Charon is the largest and most dramatic example. The one where the mass ratio is high enough and the tidal evolution is complete enough that the system has reached full mutual locking and the barycenter has been pulled into open space. But it exists on a continuum of binary and paired systems that stretches across the entire outer solar system. And this continuum raises a question that has no clean answer. A question that the International Astronomical Union has never formally resolved. When does a moon stop being a moon? The question sounds simple. It is not. Every classification system in science is an attempt to draw lines through a continuous reality, to divide a spectrum into categories that are useful for communication and understanding. And every classification system eventually encounters cases that sit on the boundary, cases where the line could reasonably be drawn on either side. Charon is one of those cases. Officially, Charon is a moon of Pluto. It is listed as such in every catalogue, every database, every textbook. The International Astronomical Union, which is the body responsible for naming and classifying celestial objects, has not created a formal definition of binary planet or double planet. Without such a definition, there is no official category for Charon to occupy other than moon. And so moon it remains, in the formal sense. But the formal sense is not the only sense that matters. The formal classification tells you what box Charon has been placed in for administrative purposes. It does not tell you how the system actually behaves. And the system behaves like a binary. The barycenter is outside Pluto. Both bodies orbit the shared center. Both are tidally locked to each other. The 4 small moons orbit the pair, not the primary. The gravitational architecture of the system is the architecture of a double world, regardless of what the catalogue says. Some planetary scientists have proposed that the barycenter criterion should be the dividing line. If the barycenter of a 2-body system lies inside the more massive body, the smaller body is a satellite. If the barycenter lies outside both bodies, the system is a binary. By this criterion, the Earth-Moon system is a planet with a moon, because the barycenter sits inside the Earth. The Pluto-Charon system is a binary, because the barycenter sits in the space between them. The line is clean, physically motivated, and easy to apply. It would reclassify Charon from moon to co-primary, making Pluto-Charon an official double dwarf planet. Others resist this approach, arguing that the barycenter location is a continuous variable that depends on mass ratio and separation, and that drawing a hard line at the surface of the primary body is arbitrary. The Earth-Moon barycenter is inside the Earth now, but the Moon is gradually receding from the Earth due to tidal interactions. In billions of years, the barycenter will migrate outward. If it eventually crosses the Earth's surface and enters open space, does the Moon suddenly become a co-planet? The physics has not changed. Only the geometry has crossed a threshold. Some scientists find this unsatisfying as a basis for classification. The debate is real, and it is ongoing, and it does not have a resolution that everyone accepts. But the debate itself reveals something important. It reveals that our categories were built for a solar system we understood less well than we do now. When the word moon was defined implicitly rather than formally, it was defined by the examples at hand. The moons of Jupiter, the moons of Saturn, bodies that were clearly subordinate, clearly secondary, clearly orbiting a dominant primary. The word worked because the examples were unambiguous. Charon is ambiguous, not because the data is unclear, but because the data does not fit the category. The word moon implies a subordinate body. Charon is not subordinate, it is a gravitational partner. The word moon implies that the primary holds the center. Pluto does not hold the center. The word moon implies that the satellite's influence on the primary is modest. Charon's influence on Pluto is fundamental. It changed Pluto's rotation. It displaced Pluto's gravitational center. It locked Pluto's orientation into space. That is not what moons do. That is what partners do. Whether the official classification ever changes is a question for the International Astronomical Union and the planetary science community. It may happen. It may not. The classification of objects in the outer solar system has been contentious since 2006, and the debate about Pluto's status, and by extension Charon's, shows no sign of concluding soon. But the classification is ultimately a label. It is a human invention, a convenience for organizing a universe that does not organize itself into neat categories. The gravitational reality of the Pluto-Charon system exists independent of what we call it, and that reality is a double world. Now let me bring this home, because there is something about the Pluto-Charon system that goes beyond orbital mechanics and surface geology and classification arguments. Something that sits at the intersection of science and meaning, the kind of meaning that a universe of ice and gravity does not intend, but that a human mind cannot help finding. Think about what the Pluto-Charon system actually is. Two worlds, frozen, dark, 5.9 billion kilometers from the sun. So far away that the sun from Pluto's surface is just a very bright star, casting light roughly 1,000 times dimmer than full daylight on Earth. The temperature on Pluto's surface hovers around minus 230 degrees Celsius, cold enough that nitrogen, the gas that makes up 78% of the air you are breathing right now, freezes solid and lies on the ground like snow. Charon is even less hospitable, an airless expanse of water ice under the same faint sunlight, with no atmosphere to hold heat, no weather, no seasons in any earthly sense. These are not welcoming places. They are not places that will ever support life as we understand it. They are not places any human is likely to visit in person for centuries, if ever. They are remote in a way that the word remote barely begins to capture. Even light, the fastest thing in the universe, takes more than 5 hours to make the journey from the sun to Pluto. A radio signal from Earth, traveling at the same speed, takes roughly 4.5 hours to arrive. When New Horizons sent its flyby data home, each image took hours to cross the gap. Pluto and Charon exist at the edge of the solar system's reach, at the boundary between the domain of the sun and the interstellar void beyond. And at that boundary, in that cold, in that dark, these two worlds are locked together. They have been locked together for billions of years, probably since within a few 100 million years of their formation, once the tidal forces did their work, slowing both rotations, synchronizing both periods, pulling each body's orientation into permanent alignment with the other. Since long before life appeared on Earth, since long before the first multicellular organisms crawled out of the oceans, since before the continents took their current shapes, before the atmosphere reached its current composition, before anything remotely resembling a human being existed anywhere in the universe, Pluto and Charon have been facing each other. The same hemisphere of Pluto has been staring at the same hemisphere of Charon for longer than complex life has existed on Earth. The arrangement predates everything in human experience by billions of years, and it will outlast everything in human experience by billions more. Pluto and Charon will still be locked together after the sun has exhausted its hydrogen fuel and begun expanding into a red giant, roughly 5 billion years from now. They will still be locked together after the sun has shed its outer layers and collapsed into a white dwarf, a dim cinder the size of the Earth, casting almost no light at all into the outer solar system. They will still be facing each other in the dark, long after the last light from the dying sun fades below any threshold of detection from Pluto's surface. Nothing will unlock them. No external force in the foreseeable lifetime of the solar system is strong enough to break the tidal bond. No passing object is likely to disrupt the system. The Kuiper Belt is sparse. Encounters close enough to perturb the Pluto-Charon orbit are extraordinarily rare, and Neptune, the only body massive enough to pose a genuine threat, is held permanently at bay by the 3-2 resonance that has protected Pluto since the early solar system. The partnership is permanent on any time scale that has physical meaning. And there is something in that permanence that catches in the mind. Two worlds that cannot turn away from each other. Two worlds that are not the same, not twins, not copies, but distinct. Different surfaces, different compositions, different geological histories, one coated in nitrogen and methane, the other armored in water ice, one with a thin atmosphere that expands and contracts with the long seasons, the other airless, one with a heart-shaped glacier, the other with a blood-red polar cap. They are different, but they are together, locked in a gravitational embrace that neither chose and neither can escape, and neither, if worlds could feel, would have any reason to regret. Because the partnership is not parasitic. It is not destructive. Charon did not diminish Pluto by binding itself to Pluto's gravity. It transformed Pluto. It converted Pluto from a solitary, icy body at the edge of the solar system into the primary member of the most dynamically interesting small body system we have ever observed. It gave Pluto a barycenter companion, a tidal partner, a gravitational counterweight that pulled the center of the system into open space and made both worlds orbit something larger than either one alone. It gave Pluto 4 additional small moons, because the small moons orbit the barycenter of the binary, and the binary exists because Charon exists. Without Charon, there is no binary. Without the binary, there is no circumbinary system. Without the circumbinary system, Pluto is just another large Kuiper Belt object, impressive in its own right, but solitary, unremarkable in its dynamical relationships, a lone world. Charon made Pluto part of something, and here is where the science becomes, if you allow it, something close to philosophy. We tend to think of the solar system in terms of hierarchy, the sun at the center, the planets orbiting it, the moons orbiting the planets, everything in its place, everything subordinate to something larger, primary and secondary, host and satellite. The big one holds, the small one follows. It is a tidy picture, and it maps well onto how we organize the world in general. Leaders and followers, centers and peripheries, main characters and supporting cast. The Pluto-Charon system breaks that hierarchy, not violently, not dramatically, quietly, by prisoning a relationship that is not a hierarchy at all. Pluto does not hold Charon. Charon does not follow Pluto. They hold each other. They follow a shared center. The relationship is not parent and child, not host and guest, not primary and secondary. It is two bodies in a mutual grip, circling a point that belongs to neither, defined by both. That is a rare thing in the solar system, and noticing it requires looking past the labels. If you read Pluto and its moon Charon in a textbook, the grammar itself assigns roles. Pluto is the noun, Charon is the possessive modifier, Pluto's moon. The language puts Charon in a subordinate position before you even get to the science. But the science does not support the subordination. The science says the center is between them. The science says both orbit. The science says both are locked. The science says the system is a pair. It is worth asking what else in the universe we might be mislabeling, because our language assigns hierarchy where the physics does not. But that is a question for another night. Tonight, the question is about Pluto and Charon. And the answer, the thing I hope you carry with you when this is over, is simple enough to say in a single sentence, Even though it took us this entire journey to understand why it is true. Charon did not just orbit Pluto, it turned Pluto into half of a double world. It did this through its mass, 12% of Pluto's, enormous by the standards of any other moon to primary ratio in the solar system. It did this through its proximity, only 19,570 kilometers away, close enough for the tidal forces between them to reshape both bodies' rotations within a few 100 million years. It did this by displacing the barycenter, pulling the gravitational center of the system out of Pluto's body and into the void between them, so that both worlds orbit a point that neither contains. And it did this by locking Pluto's rotation to its own, freezing both bodies in a permanent mutual gaze that will endure for as long as the solar system exists. The Pluto that most people picture when they hear the name, the lonely little world at the edge, the demoted planet drifting in the dark, that Pluto does not exist. The real Pluto has never been alone. Not since the impact that created Charon, billions of years ago, in the violent early history of the Kuiper Belt. Since that moment, Pluto has been one half of a pair, one member of a binary, one world in a double system, locked to its partner, circling a shared center, carrying 4 small moons in tow as the whole system traces its 248-year orbit around a distant sun. And Charon, the companion that made all of this true, the object that most people have never heard of or think of only as a footnote to Pluto's story, is the reason. Charon is not a footnote. Charon is the other half, the counterweight, the body that transformed the system from a solitary dwarf planet into something more complicated, more interesting, and more beautiful than a single world could ever be. Out there, right now, at the edge of the solar system, 5.9 billion kilometers from where you are sitting, 2 frozen worlds are facing each other in the dark. They have been facing each other for longer than life has existed on Earth. They will be facing each other long after everything we have built is gone. Neither can turn away. Neither is in charge. They orbit the space between them, a space that exists because they exist, defined by their combined gravity, belonging to neither one alone. That is what a double world looks like, not identical, not equal, but partnered. 2 bodies, each distinct, each complex, each carrying its own scars and its own chemistry and its own history, bound together around a shared center in the outer dark. Pluto is not a lonely exile. It never was. And the companion that proved it, the moon too large to behave like a moon, has been there all along, staring back, permanent and patient and strange. Good night.